Imagine a world without electricity, without motors, without the invisible forces that power our homes, industries, and technologies. Now imagine a young boy born into poverty with no formal education, no wealth, and no social standing, yet destined to unlock the very secrets of electromagnetism that would revolutionize civilization. This is the story of Michael Faraday, a self-taught visionary who rose from a bookbinder's apprentice to one of the greatest experimental physicists in history. His discoveries paved the way for electric power generation, wireless communication, and the very fabric of modern physics. But Faraday's legacy is not just about science. It's about relentless curiosity, unwavering humility, and the belief that knowledge should serve humanity, not personal ambition. He defied class barriers, challenged the scientific elite, and inspired Albert Einstein, James Clerk Maxwell, and generations of innovators. From his groundbreaking work in electromagnetic induction to his timeless Christmas lectures, Faraday's influence stretches far beyond the laboratory. This is the extraordinary journey of the man who illuminated the world, not with wealth or privilege, but with the power of discovery. The streets of Newington Butts, a small suburb of London, bustled with the daily struggles of working-class families. Among them was the Faraday household, modest, hardworking, and deeply religious. It was in this setting, on September 22, 1791, that Michael Faraday was born, the third of 4 children in a family that knew hardship all too well. His father, James Faraday, a blacksmith, labored tirelessly despite his frail health, while his mother, Margaret Hastwell Faraday, managed their meager resources with unwavering resilience. The Faradays belonged to the Sandemanian Church, a small Christian sect that emphasized humility, discipline, and the pursuit of knowledge, values that would later shape Michael's character. Unlike the privileged sons of wealthy families, Michael received only basic schooling, learning little more than reading, writing, and arithmetic. At the age of 13, he left formal education to work as an apprentice to George Rebow, a local bookbinder and bookseller. This, however, was no ordinary job. It was an open door to a vast world of knowledge. Michael's hands tirelessly folded, stitched and bound books, but his mind devoured the words within them. He immersed himself in texts on electricity, chemistry, and natural philosophy, with a particular fascination for Jane Marcet's Conversations on Chemistry and Encyclopedia Britannica's entry on electricity. The works of Isaac Newton and Humphrey Davy ignited a fire in him, setting his mind alight with curiosity. Each evening he would meticulously copy diagrams, take notes, and conduct rudimentary experiments with crude materials. Though he lacked formal education, he compensated with an insatiable thirst for knowledge. What seemed like an ordinary apprenticeship would soon turn into the foundation of an extraordinary scientific journey. Little did the world know that this humble bookbinder's apprentice would one day redefine the very fabric of electromagnetism and modern technology. By the time Michael Faraday completed his apprenticeship at age 20, he was no longer just a bookbinder. He was a self-educated scholar, brimming with knowledge and curiosity. Yet, the world of science was a distant realm, seemingly reserved for men of wealth and privilege. He needed an opportunity, a gateway to the very heart of discovery. That opportunity came in 1812, in the form of a public lecture series at the Royal Institution, delivered by the esteemed Sir Humphrey Davy. Davy, a celebrated chemist, had made groundbreaking discoveries in electrochemistry and was widely admired for his lectures. When Faraday, eager but humble, attended the lectures, he sat among the crowd, hanging on to every word. But he wasn't just a passive listener. He took detailed notes, sketched apparatus, and compiled them into a bound book which he later presented to Davy with a bold request: a job in science. At first there was no position available, but fate intervened. Later that year, Davy was injured in a chemical explosion and required a temporary assistant. Remembering the keen young man with the meticulously compiled notes, he offered Faraday a short-term position. It was the opportunity Michael had longed, for Faraday joined the Royal Institution as Davy's laboratory assistant, working side by side with some of the greatest minds of the era. At first, his duties were menial: cleaning glassware, preparing chemicals, and setting up experiments. But he observed, listened, and learned, absorbing the intricacies of experimental science. Despite his lack of formal education, Faraday's enthusiasm and sharp intellect quickly impressed Davy. When the famed chemist embarked on a European scientific tour, he invited Faraday to accompany him, a journey that would expose the young apprentice to the greatest scientific minds of the time, from Alessandro Volta in Italy to André-Marie Ampère in France. This voyage was more than an educational tour, it was a transformation. From a humble bookbinder's apprentice, Michael Faraday was now stepping into the world of great scientific discovery. But this was just the beginning. As Michael Faraday traveled across Europe with Sir Humphrey Davy, he found himself surrounded by the towering figures of science. He witnessed experiments, engaged in discussions, and absorbed the very essence of scientific inquiry. But while this journey was an education, it was also a test of character. Despite his brilliance, Faraday was still seen as an assistant, not an equal. The rigid class distinctions of the time meant that a self-taught bookbinder's apprentice could not easily ascend to the ranks of distinguished scientists. Worse still, Davy's wife, Jane Priest Davy, treated him as a mere servant, forcing him into demeaning tasks and reinforcing his outsider status. Yet Faraday remained resolute. Every experiment he observed, every scientist he met, Alessandro Volta, André-Marie Ampère, and Jean-Baptiste Biot, added to his growing understanding of electricity and magnetism. Even when dismissed by some as an uneducated assistant, he was patient. He knew his time would come. In 1815, after 2 years abroad, Faraday returned to London and the Royal Institution. Though still working under Davy, he began conducting his own experiments, particularly in chemistry. His first breakthrough came with the study of chlorine compounds, which led to his discovery of benzene, a fundamental organic molecule. His meticulous research and uncanny intuition for experimentation set him apart. By 1820, Faraday was no longer just an assistant. He was a respected chemist in his own right. His work on gas liquefaction, steel alloys, and electrochemistry gained recognition, but he had yet to make his greatest contribution. Even as his mentor and benefactor Davy grew distant and began resenting his success, Faraday pressed on. He had learned much from his travels, but now it was time to carve his own path in science. By the early 1820s, Michael Faraday had already made a name for himself as a skilled chemist, but his true passion lay elsewhere: electricity and magnetism. At the time, electricity was still a mysterious force, studied mostly in isolation from other natural phenomena. But a groundbreaking discovery in 1820 by the Danish physicist Hans Christian Ørsted would change that. Ørsted demonstrated that an electric current could deflect a magnetic needle, suggesting a deep connection between electricity and magnetism. Scientists across Europe, including André-Marie Ampère and Jean-Baptiste Biot, rushed to understand this phenomenon. But it was Faraday who would take it a step further, from observation to application. In 1821, Faraday conducted a crucial experiment that would forever change physics. He designed a simple apparatus consisting of a wire carrying an electric current placed near a magnet in a pool of mercury. When the current was switched on, the wire began to rotate continuously around the magnet. It was the first demonstration of electromagnetic motion, the principle behind the electric motor. Without realizing it, Faraday had paved the way for modern electrical engineering. But at the time, his discovery was met with skepticism. Many believed that the connection between electricity and magnetism was merely a curiosity with no real-world applications. Even Humphrey Davy, once his mentor, began to see Faraday as a rival. By now, Davy's career was fading, and his jealousy grew as his former assistant made discoveries of his own. Despite this resistance, Faraday remained humble and determined, continuing to explore the relationship between electricity and motion. His next challenge was even greater. Could electricity be generated from magnetism? If so, it would mean the possibility of generating continuous electrical power, a concept that did not yet exist. Faraday was on the verge of unlocking one of the greatest scientific breakthroughs in history, the discovery of electromagnetic induction. By the early 1830s, Michael Faraday had already demonstrated that electricity could create motion through magnetism. But now, he sought to answer a far more ambitious question. Could motion generate electricity? At the time, the only way to produce electricity was through chemical reactions in voltaic piles, early batteries. If Faraday could prove that a simple magnet in motion could induce an electric current, it would revolutionize science and industry. In 1831, after countless experiments and failures, he set up a groundbreaking experiment. He wound two separate coils of wire around an iron ring, with one coil connected to a battery and the other to a galvanometer, a device to detect electric current. When he activated the battery, he noticed a momentary deflection in the galvanometer. An electric current had been induced in the second coil, even though they were not physically connected. It was a monumental discovery. A changing magnetic field could induce electricity. But Faraday didn't stop there. He refined his experiment using a simple copper disc rotating between the poles of a horseshoe magnet. To his amazement, the motion of the disc generated a continuous electric current. He had created the world's first electric generator. This discovery, known as electromagnetic induction, laid the foundation for the development of dynamos, transformers, and the entire electrical industry. Without it, modern power generation from hydroelectric dams to wind turbines would not exist. Faraday's findings were met with awe and admiration. Even those who had doubted him, including the Royal Society and his former mentor Humphrey Davy, could not ignore the profound implications of his work. With electromagnetic induction, Faraday had not only answered his question, he had ushered in the age of electricity. With the discovery of electromagnetic induction in 1831, Michael Faraday had laid the foundation for the generation of electrical power. But his insatiable curiosity pushed him further. He wanted to understand the very nature of electricity itself. At the time, many scientists still viewed electricity as a fluid-like substance that flowed through wires. But Faraday believed it was something more, an invisible force that obeyed deeper laws of nature. To test his theories, he conducted a series of experiments that would have lasting implications for physics and engineering. One of his most famous experiments led to the discovery of the Faraday Cage. In 1836, he demonstrated that an enclosed conductor could block external electrical fields, protecting anything inside from electrical charges. To prove his point, he constructed a large metal box, stepped inside, and had his assistants charge the exterior with high-voltage electricity. To the amazement of onlookers, Faraday remained completely unharmed inside. He had just proven that electric charges reside only on the exterior of a conductor, a principle that today protects aircraft, cars, power stations, and sensitive electronics from lightning and electromagnetic interference. But Faraday's investigations didn't stop there. He was paving the way for the understanding of electric and magnetic fields, a concept that would later inspire James Clerk Maxwell to develop the famous Maxwell's equations, the foundation of classical electromagnetism. Despite his growing fame, Faraday remained humble. He turned down offers of knighthood, refusing to be called Sir Michael Faraday, and declined prestigious positions that would take him away from experimental work. For him, science was not about titles or power, it was about discovery and truth. Even as he aged, his mind remained sharp. His next great breakthrough would challenge the very way the world saw light and magnetism. By the 1840s, Michael Faraday had already revolutionized the understanding of electricity and magnetism. But his curiosity led him to explore an even deeper question. Could light and magnetism be connected? At the time, electricity, magnetism, and light were studied as separate phenomena, with no clear relationship between them. But Faraday had a hunch. What if they were all part of the same fundamental force? In 1845, he conducted a remarkable experiment. He placed a piece of heavy glass inside a powerful magnetic field and sent a beam of polarized light through it. To his astonishment, the plane of polarization rotated as it passed through the glass. This was a monumental discovery. Faraday had just demonstrated that magnetic fields could influence light, proving for the first time that electromagnetism and optics were connected. This phenomenon, now known as the Faraday effect, was the first evidence that light itself was an electromagnetic wave. His findings were ahead of their time. The full implications wouldn't be understood until decades later, when James Clerk Maxwell mathematically unified electricity, magnetism, and light in his famous Maxwell's equations. Without Faraday's insight, Maxwell's work might never have been possible. Faraday's belief in the unity of forces extended beyond electricity and magnetism. He speculated that all fundamental forces of nature, electricity, magnetism, light, and even gravity, were deeply interconnected. Though he lacked the mathematical tools to prove it, his intuition was prophetic. Centuries later, physicists would continue to search for a grand unified theory that could unite all forces of nature. Despite his aging body, Faraday's mind remained as sharp as ever. His discoveries continued to shape the scientific world, and his influence extended beyond the laboratory. Soon, he would become one of the most beloved educators in Britain, inspiring future generations of scientists. By the 1850s, Michael Faraday was no longer just a scientist. He had become a mentor, lecturer, and inspiration to countless young minds. Though his discoveries in electromagnetism and optics had already transformed science, his greatest passion remained education and public outreach. At a time when scientific knowledge was often reserved for the elite, Faraday sought to make complex ideas accessible to everyone. Now a senior figure at the Royal Institution, he began delivering public lectures which soon became legendary for their clarity, energy, and engaging demonstrations. His most famous contribution to public science was the Christmas lectures for young people, which he initiated in 1825 but perfected in the later years of his career. These lectures, covering topics from electricity and magnetism to the nature of gases, were designed to ignite curiosity in children and the general public. Faraday's ability to simplify profound scientific principles made him one of the greatest science communicators of his time. One of his most famous series, The Chemical History of a Candle, explored the properties of combustion through a simple yet profound experiment, a burning candle. He used this everyday object to explain the principles of chemistry, physics, and even the conservation of energy, inspiring generations of students and scientists alike. Despite his fame, Faraday remained humble and uninterested in wealth or status. He repeatedly declined prestigious offers, including a knighthood from Queen Victoria, stating that science should be pursued for knowledge, not personal gain. Yet, even as he continued to teach and inspire, age began to take its toll. By the late 1850s, signs of memory loss and cognitive decline started to appear. Though his mind had once illuminated the mysteries of electricity and magnetism, it was now beginning to fade. But Faraday's legacy was already secured. His discoveries had transformed the world, and his lectures had shaped the next generation of scientists. As his health declined, he withdrew from public life, spending his final years in quiet reflection. The world was about to lose one of its greatest scientific minds. By the 1860s, Michael Faraday had given everything to science. His discoveries had redefined electricity and magnetism, and his lectures had inspired generations. But now, in his 70s, his once brilliant mind was beginning to fade. The signs had been subtle at first: forgetfulness, lapses in concentration, difficulty recalling details of experiments he had once performed with ease. Over time, the symptoms worsened. By 1865, Faraday was forced to retire completely from scientific work. Recognizing his immense contributions, Queen Victoria offered him a house at Hampton Court, a quiet retreat near the River Thames, where he could live out his final years in peace. Though he accepted the home, he declined the title of knighthood as he had done many times before. Faraday sought no honors, no power, only knowledge and truth. Despite his declining health, his humble spirit and deep faith never wavered. A lifelong member of the Sandemanian Church, Faraday found comfort in his religious beliefs, often stating that his work in science was a means of understanding God's creation. Visitors would still come to see him, hoping for one last glimpse, of the man who had changed the world. Though his memory was failing, he remained kind, curious, and warm-hearted. He spent his last years reading, walking along the Thames, and reflecting on his life's work. On August 25, 1867, at the age of 75, Michael Faraday passed away peacefully in his home. He had no grand funeral, no elaborate memorial, just a simple burial at Highgate Cemetery in accordance with his wishes. Though he was gone, his legacy was eternal. The very foundations of modern electricity, magnetism, and electromagnetism bore his name. His discoveries had not only shaped the Industrial Revolution, but they would continue to power the modern world for centuries to come. Yet, Faraday's impact was not just in science. It was in the way he inspired others to seek knowledge for the sake of understanding, rather than for personal gain. And that, perhaps, was his greatest discovery of all. Though Michael Faraday passed away in 1867, his influence never faded. In fact, his discoveries in electromagnetism, chemistry, and optics laid the foundation for the modern technological world. His most profound contribution, electromagnetic induction, led directly to the invention of electric generators, transformers, and motors, devices that power everything from household appliances to global electrical grids. Without his work, the Industrial Revolution would have stalled, and the age of electricity may have come decades later. But Faraday's impact was not limited to engineering. His discovery of the Faraday effect, which revealed the link between light and magnetism, helped inspire James Clerk Maxwell, who would later develop Maxwell's equations, the mathematical foundation of electromagnetic waves. This work ultimately led to the development of radio waves, radar, X-rays, and even modern telecommunications. Even today, countless technologies owe their existence to Faraday's discoveries. His pioneering work enabled electric power generation, power plants, dynamos, and turbines, electromagnetic shielding, Faraday cages used in airplanes, MRI machines, and electronic security, wireless communication, radio, television, and cell phones based on Maxwell's equations, which were inspired by Faraday, battery technology, and electrochemistry, essential for electric vehicles and renewable energy storage. His contributions were recognized worldwide. The unit of capacitance, the Farad F, was named in his honor, and his name is etched into history as one of the greatest experimental physicists of all time. Albert Einstein kept a picture of Faraday in his study, alongside Newton and Maxwell, as a reminder of his genius. But perhaps Faraday's greatest legacy was his ethos of humility, curiosity, and integrity. He pursued science not for wealth, titles, or fame, but for the pure joy of discovery. His Christmas lectures at the Royal Institution still continue today, over 200 years later, inspiring new generations of scientists. Michael Faraday was more than a scientist. He was a visionary, a teacher, and a pioneer of the modern world. His discoveries continue to illuminate, power, and connect our lives in ways he could never have imagined. And so, every time we switch on a light, power a device, or hear a radio transmission, we unknowingly honor the legacy of the humble bookbinder's apprentice who unlocked the secrets of electricity and magnetism. Michael Faraday changed the world, not with wealth, not with privilege, but with knowledge, passion, and an unbreakable spirit of inquiry.